Hi everybody, this is lesson 76, Algebra 2, and this lesson covers using both substitution and elimination in negative vectors. Okay, so this is a system of 3 equations, and to solve this, we're going to have to use both methods that we've learned here, substitution and elimination. Alright, so we've already got an x equals. So what we're going to do is go ahead and plug that into one of these equations. So I'm going to start with this x plus y plus z equals 9, and I'm going to substitute in my 2y for x. So I've got x plus y plus z equals 9. So my x becomes 2y right there, plus y plus z equals 9. Okay, so here I can put, wait, that should be 2y. Yep. 2y, because x equals 2y. Now I can put these y's together, and I'll have 3y plus z equals 9. And what I'm trying to do is I'm trying to solve for z. So I'm going to say minus 3y. And I'm going to get z equals 9 minus 3y. Okay, now I can plug that into that equation. So I've got x minus 3y minus 2z plus, not plus, that's supposed to be equals negative 8. Let me fix that. There we go. Equals negative 8. Typo, whoopsie. Okay, so x minus 3y minus 2z equals negative 8. Okay, so I can put my x value in as 2y minus 3, y value in, oh, we don't have a y value, 3y minus 2z, our z value is right here, 9 minus 3y equals negative 8. And now I'm down to one variable. The only variable in here is y. Alright, 2y minus 3y, that would be negative y minus 2, see, 2 times 9, that would be 18, minus 18, and that would be plus 2 times 3 is 6y equals negative 8. Okay, now I can put these y's together, and that would be 5y minus 18 equals negative 8. Now I'm going to do plus 18 on both sides. And I get 5y equals 10. And I get y equals 2. Okay, so my y equals 2. So now I can figure out what z is. Z equals 9 minus 3 times y, which is 2. 3 times 2 is 6, so z equals 9 minus 6. 9 minus 6 would be 3, so z equals 3. And now I can figure out what x is. X equals 2y, and y is 2. 2 times 2 is 4. Two, 3, and 4. Alright, so these are pretty easy. You just have to first off, find one with an x there. Solve for one variable, then solve for y. You're not going to have it completely, right? Or z, or whatever you can solve for. And then just got to break it down to where you've only got one variable at a time. Alright, on this one, the first thing I'm going to do on this one, we don't have an x equals, so I'm going to move this bottom equation around right here to get my x by itself. So I'm going to say x minus 3z equals 0. So now I'm going to do plus 3z, and I'm going to get x equals 3z. Okay, then I'm going to substitute that value into this top equation. So I'm going to say 2x, which is 3z, plus 2y minus z plus, oops, I did that again. I got another typo. So that means that, let's see, what is that? That's supposed to be equals. Equals 12. Sorry about that. It's typing fast. Alright, so where am I? Minus z equals 12. There we go. So 2 times x, which is 3z, plus 2y minus z equals 12. Alright. So I'm going to rainbow right here. 6z plus 2y minus z equals 12. Okay, now I'm going to put my z's together. That'll be 5z plus 2y equals 12. Okay. Let's see. I can't really solve for one or the other on that one. So you may run into that. So let's try plugging this x value into this middle equation. So I got 3x, which is 3z, minus y plus 2z equals 21. Alright, so that'll be 3 times 3, 9z minus y plus 2z is 21. Now I can put these two together. That'll be 11z minus y equals 21. And then minus 11z. Okay, now I have negative y equals 21 minus 11z. And now I can just change the sign on all of these. And we're going to have y equals, so I just multiplied the whole thing by negative 1. So now I've got y equals negative 21 plus 11z. Or we could write that the other way, which would make more sense. 11z minus 21. Alright, now I can plug that value in for y. We can plug it in right here. So we could say 5z plus 2 times y, which is 11z, minus 21 equals 12. Now we're going to rainbow right here. 20 plus 22z minus, that would be 2 times 21 would be 42 equals 12. Now we're going to add 42. And we can put these two together, so that will be 27z equals 54. Okay, and then we just need to divide by 27. Divided by 27. 7 times, 3 times 7, 2 times 7 is 14. 2 times 2 is 4, 5, yep, 2. So we've got x, y, and z. And z is 2. Alright, so now we can solve for the other ones pretty easily. So if x equals 3z, z is 2. 3 times 2 is 6. X equals 6. Okay, and then for y, y equals 11z, which is 2, minus 21. Y equals 22 minus 21. Y is going to equal 1. Alright, so on these, if you plug something into one of these equations like we did at the top and you can't come up with an x or a y by itself, try the other equation. Or just start by looking for an equation with the y by itself. So here we had the x by itself, here we had the y by itself. Those are the ones we want to use first. Okay, so the next part of this lesson is about adding negative vectors. So first we're going to draw this vector right here. So this is -4, -20 degrees. So if we did -20 degrees, that means we went backwards 20 degrees. So right there, okay? Now a negative vector means that instead of going out forward this way, we're going to go backwards forward that way. Okay? And it's right there. Okay, so here's our negative 20 degrees. We went down, but then we went backwards. So if you have a negative number here, right, then that means you're going to go backwards that way, okay, instead of the direction that you normally would go. All right, so we draw that vector, and that would be 4 for our hypotenuse. This is 20, because if this is 20 degrees right here, then that would be 20 degrees, right? Would it though? Yes, it would be 20 degrees, because this would be a straight line. It seems like that would be 20 degrees. Let's see. Let me draw that better. It looks a little confusing. Okay, so we're going to draw it nice and big so we can see what we're doing. Okay, and we went down 20 degrees, okay, and that goes up. Oh yeah, right here would be 20 degrees. That's what I thought it was. All right, and if this went out 4, this will be positive 4 from there to there, okay? So from here to here is going to be negative 4. There's our 4. Okay, and there's our 20 degrees there. All right, so now we've got the opposite and the adjacent, okay? And sine equals opposite over adjacent, so cosine equals, no, opposite over hypotenuse. And cosine equals adjacent over hypotenuse. Our hypotenuse is 4, so the sine of 20 degrees equals opposite over 4, so times 4 times 4. So we need the sine of 20 degrees times 4. So we're just going to say 20 sine times 4, and we get 3.65. That's not what it says in the book. So, I've got it in red. I need degrees. All right, so clear that. Make sure you have your calculator in degrees when you do this. 20 sine times 4. There we go, 1.368. The book has it as 1.368. All right, so we're going to put that down. So that will be our opposite, 1.368. Okay. Right there. Okay, and then our adjacent, we're going to do that cosine times 4. Cosine 20 degrees. 20 cosine times 4. 3.758. We're going to round that up to 3.759. So right here, 3.75. The book went with 88. Okay, so there's that one, and there's that one. That is how far we go up. So that this would be, if we turn this into, rectangular coordinates, we're going to have 1.368. Oh, I got to do my left and right first. Whoops. Okay, so we're going to have negative 3.7588R, because we went left, so that's negative, plus 1.368U. All right, now we're going to do this other one. Okay. Get rid of all this. And this is 135, right? So we are going to go this way, 135, so that's 90. 135 is going to be about there. All right, so we got to figure out what this angle is. So 180 minus 135 . 45. So our angle is 45 degrees. And we went out 5. Okay, so we're going to have to find our opposite and our adjacent. So we're going to say sine of 45 times 5. So 45 sine times 5, 3.5355. Or this one, 3.5355. And then we'll use cosine for the other one. So 45 cosine times 5, 3.5355. It's the exact same. 3.5355. Oh, because it's a 45, so that means that those are equal to each other. All right, so this would be negative 3.5355 R plus 3.5355 U. Okay, so now it asks us to add those. So I'm going to add up that and that. So that would be 3.5355 plus 3.7588. $7.29433. So we're going to have 7.2943. Since we're adding these, right, we're just adding like terms. Here's our rights, okay, and those are negative, okay, and then we've got a positive and a positive for our ups. So this would be 3.5355, 3.5355 plus our other up, 1.368. 1.368. 4.9035. 4.9035 up. That was right. There we go. So we add our R's and we add our U's. And we can round this to negative 7.29 R plus 4.90 U. And there is the answer to that. Alright, so that's how you add vectors. Go ahead and pause the video and work those practice problems, then I'll come back and work them for you. Alright, so we're going to start off with this one, system of 3 equations. We've got an x equals, so I like that. We're starting out good. Alright, and this one has a y by itself, and a z by itself, so we're going to try that one. So we're going to say x plus y plus z equals 56, and we're going to plug in this 3y value into that x. So we're going to say 3y plus y plus z equals 56. Now we're going to put our like terms together and get 4y plus z equals 56. And now we're just going to subtract our 4y from both sides. That way we get z by itself. Z equals 56 minus 4y. Okay, so now we have a value for z that we're going to plug into this bottom equation. So our bottom equation is x minus 2y minus 3z equals negative 25. X minus 2y minus 3z equals, yep, okay. So then we're going to plug in our x value, which is 3y, minus 2y, y is the only variable that we don't have yet, whoops, minus 3z, here's our z value, 56 minus 4y equals negative 25. Okay, so now we're going to put these y's together. That will give us 1y. And now we're going to multiply 3 times 56. 3 times 6 is 18. 3 times 5 is 15, 16, 168. And that is negative. I don't know why I have an equals there. That doesn't need to be there. Alright, so we got 3y minus 2y would be 1y. And then negative 3 times 56 would be negative 168. Okay, now you have to rainbow to here. 3 times 4 is 12, and that would be positive 12y equals negative 25. Alright, so now we have two more y's we can put together. So that's going to be 13y minus 168 equals negative 25. Okay, now we're going to add 168. We're going to get 13y equals, okay, so we've got 168 minus 25. 8 minus 5 is 3. 6 minus 2 is 4. 143. Okay, and now we're going to divide by 13. 43. One time. 11. So y equals 11. Alright, so we've got x, y, and z we're looking for, and y is equal to 11. Okay, so if x equals 3y, x equals 3 times y is 11, x is going to equal 33. And z, we're going to plug it in over here. So we're going to say z equals 56 minus 4y, which is 11. Z equals 56 minus 11 times 4 is 44. So we have 56 minus 44. 6 minus 4 is 2, 12. So z equals 12. So you should have 33 for x, y is 11, and z is 12. There's the answer to that one. Okay, one more practice problem. Alright, so this one, we're going to do our polar coordinates. So for this first one, we've got negative 15 degrees, so that means we went down this way. 15 degrees, negative 2. So that means this is 15 degrees. And we went backwards 2. Right, so there, and that's 2. Okay, and now we have to figure out what these are. This will be our opposite. That will be our adjacent. So we're going to say the sine of 15 degrees times 2. It's 0.5176. 0.5176. And then for our adjacent, we're going to say 15 cosine times 2, 1.9318. 1.9318. Okay, so we went negative 0.5176, right, and then we went up, no, that's not right, other way around. We went negative 1.9318, or positive 0.5176 up. Okay, now we're going to do this one. It's 110, so when we go 110 degrees, we're going to go backwards this way. Okay, and the whole thing will be 180, so 80 minus 10 would be 70. So this part's going to be 70. Okay, and then this goes out 5. So right there, that part's 5. So this is our opposite. That's our adjacent. What was it? 70. So we need the sine of 70 times 5. .698. Okay, and then cosine of 70 times 5. .710. Right. Yes. Okay, so we went negative 1.710 minus now that's to the right, plus 4.698 up. Now we just got to put these together, so we're going to add our like terms. So 1.9318 plus 1.710, 1.9318, 0.9318, yep, 3.648, so we're going to make that be 3.64. And then we need 4.698. And we're adding that, so we're adding that one and that one, 0.5176. 5.2156. We can round that up to 5.22. And there's the answer. So hopefully you got something close to that. If not that, just round it when you get to 2 decimals. And you notice I didn't round until the end, so don't round until you're adding them together. Round it to about 4 decimals and then add them and then round to 2. Alright, so that is it for lesson 76. Thanks for watching.